Hey everyone, welcome to this VPL tutorial. Today we'll be considering the biological problem of finding all genes in an organism that have a certain sequence length. So to start off, let's see what kind of organisms we have loaded. Alright, on this machine we have two organisms loaded, Prochlorococcus and Nostoc punctiforme. Let's decide we want to deal with just one of those. So we've got this handy little second function, and I can copy this answer up here, paste it here, and that will give me the second thing in this list. And there it is. Now I can deal with just this organism, Nostoc punctiforme. So we said we wanted to find all the genes of a certain sequence length in that organism. Well, how do we get all the genes of an organism? Fortunately, we have a function for that. Genes of. Pretty simple. So, again, let's copy this into genes of. Alright, and let's execute it. It looks like that worked. We've got a whole bunch of genes. We can make the results screen a little bigger. We can make it even bigger. So you can see there are at least 100, and probably more because of this little trailing ... Okay, what we really want to do is examine each one of these genes individually and check the sequence length. And if it's more than, let's say, 2000, then we want to put it in our answer. So how do we do that? Let's bring down this for each function. What for each does is what I just described. It's going to examine each thing in the collection of things, do something to it, and it can return whatever you want. So this first option is called variable in collection. Again, what this means is that we'll be examining this whole giant list one at a time. This thing I have highlighted is the first gene. Here's the second gene, and so on. So since we'll be dealing with genes, each thing that we're operating on at a time, we're just going to call gene. Now, how do we get this giant list into this collection box? Well, pretty simple. We know that this giant list came from this genes of box. So let's use the cut insert feature to move that over. Great. Now let's skip down to the results section because we're going to need to know what kind of results we want. And let's click this when collect option. Now, we're looking for genes that have a sequence length that is greater than 2000. So let's click this condition, and let's look for some kind of numerical comparison. Here we go. Greater than. Great. So we're looking for things that are greater than 2000. But how do we get the length of the gene? Well, let's click here, go up to genome, and look, something called length of. Now, length of, you might think, is talking about strings or lists. Can it really work on a gene? Let's click help and check the documentation. Excellent. It can take a gene, and here's an example of that. Okay, now we type in gene. Again, it's not just because we're dealing with genes, it's because that's what we decided to call each individual gene up here. Now, when it is greater than 2000, we want to collect that gene. And again, we're not calling it gene because we're dealing with genes, we're calling it a gene because that's what we decided to call it up here. If we wanted to call it something else, we could do that. We could call it G, but if we did that, we'd have to go change all of these. So let's stick with that. So, this will collect only genes that have a sequence length of greater than 2000 and ignore the rest. So let's see if it works. It looks like it did. You can see the 6th gene, the 17th gene, the 20th gene, the 25th gene, and so on. Lots of genes have sequence length greater than 2000, but we can see that a lot of them don't. So I hope this was helpful. That's the first video.